So, good morning to all. So, we will continue where we left in the last lecture. So far within the brake system design, we have discussed about brake working methods, brake types, brake torque requirement. Within that, drum brake system, disc brake system, all these things we have discussed. In dynamic analysis, we've been discussed about the mass transfer during the braking aspect, and also we have discussed the brake distribution between the front axle and the rear axle as well. Now we will continue with the brake force distribution, and also we are going to learn about the optimum aspect as well. Okay. So before going to things, I would like to recap what we have discussed about the brake distribution. First, please understand there are three different coefficient of friction we do have in this brake system. One is a mu or mu L, it nothing but coefficient of friction of brake line, right, brake lining, that is a one mu. The other one is mu R, coefficient of friction right in rolling, that is between tire and ground. Okay. This is the one. The third one is a mu S, is called road addition. Okay. Road addition coefficient or coefficient of friction of road. Okay. Road, particularly we are talking about the road and tire interface. This is what we have discussed. And also we found the front axle reaction forces NFA, right. We found W L2 H PB mu R W divided by L. Similarly, the reaction force from the rear axle NRA is W1 minus, will you expect, then the remaining things are same, right, L. Please understand this WL2, right, or L2 by L, right, it is a static load, correct, right, it is a static load for front axle, whereas L1 by L is a static load again for your rear axle, obviously, right, L2 by L, that is what is happened. Okay. Then we found the maximum the braking force, right, which developed at the interface. When I talk about, so when the vehicle is moving, right, so when you apply the brake force is developed between the wheel and tire, BB max for front axle. Okay. Front axle we got mu S, right, WL2 plus H PB mu R W divided by L. This is the one we have. Similarly, PB max for rear axle RA mu S WL1 minus of H PB mu R W divided by L. So this is what we found. And also what we have taken, we have taken the proportion of these two equations, right? We have taken the proportion of these two equations, and finally we arrived at, it's a KB FA divided KB RA, same equation, maybe you can say A and B, right? So finally when you divide, this will strike off, this goes off, you will expect WL2 H maybe mu r W divided by WL1 minus, I think the W also goes out, okay, when your W also goes out, in fact I will rewrite the equation, right. It should be, when you take the W out, that will also cancel out, finally you expect L2 H mu s mu r, yeah, I think this is correct, L1 minus H mu s plus mu r, this is what we got it, right. This is nothing but your break distribution, this is called break distribution, maybe I will distribution, okay, this we have, right. Again we will clarify one more thing is the KB FA, it is a break distribution at front axle, right, it is a front axle, KB RA break distribution at rear axle, right. For given that the KB front axle plus KB rear axle must be equal to 1, this is what we said, am I right? Okay, that is what we did. And also we have discussed what we have said. So the entire thing, right, the braking distribution is depends upon the hydraulic pressure of your brake fluid as well as wheel cylinder. Based on that, the proportion is determined. In fact, whatever the braking force or normal force generated during the braking must be balanced with the distribution which is happening in the hydraulic pressure as well as the wheel cylinder. Okay, that is what we have discussed. And also we have discussed one more important thing. So this is the proportion we need to have it, okay, this is the proportion we need to have it, and the brake forces, what are the brake forces? When you talk about brake force, please remember this is the your braking distribution, brake force I am talking about your PB, right, PB FA front axle and PB at the rear axle, right. The brake forces should be developed at the same time in all 4 wheels, okay, they have to develop the braking force effect at the same time in all 4 wheels, that is supposed to be happen, but generally it won't happen. Either front axle lock first or else, right, the rear axle lock first. So what do you mean by lock first? What do you mean by lock firsting? Right. What do you understand about that? When do you expect? Let me go again. Yeah. So this is, I am just showing the only one wheel. Okay, the one wheel I am showing that. This is there, and assuming that the vehicle is moving in direction, obviously the rotation would be clockwise, right, anti-clockwise, the rotation is anti-clockwise. Sir, so the moment right is going this direction, you would expect this is your N, right? This is N. Assuming for front axle doesn't matter, okay. And this is your, so the moment you apply the brake, right? So this already the load is acting, the load is there. I am not showing the load, but assuming it's a load is there on the wheel. So this is the normal force, and this is the where you are expecting your the braking force. The question is, when do you expect the self locking? When do you expect the self locking? So what is the this one is indicate about your mu s, right? This is indicate about the road adhesion factor or coefficient of road. That's what is happening. So the moment the braking force whatever is developed is must be equivalent to mu s into W. So in that condition, what do you expect? This, so this has to be balanced, right? So what are the braking force is developed must be equal to your mu s into W. In this condition, you are going to have a self locking, right? Self locking. So until then, the tire keep rotating, it's rolling, it's rolling. So at that point, when you have a brake force, right? So the rolling is stopped. So that's why this is called self locking, okay. This is this condition called self locking. Yeah, this is condition called self locking. So in fact, we will go ahead to discuss in detail furthermore and understand that yeah. So now we will talk about the road adhesion coefficient mu s. Look at this, is given for various conditions. This is for the asphalt and concrete is 0.8 to 0.9 is clearly given. The moment you go for wet surface is drastically reduces your road adhesion factor, okay. I'm sure you would have known or you would have seen during when you drive during the rainy season, right? It's always skiddy. Why skidding is happening? Skidding is happening because of your friction is drastically reduced during the wet, okay. But look at if you have a concrete, when you have a concrete surface, what I said earlier, asphalt nothing but your tar road, okay. The moment I am talking about concrete, even though it's in wet condition, the coefficient of adhesion, road adhesion is almost same. Now you know that why it's a concrete roads are preferred than the your asphalt, right. So that you will understand that, okay. And that is the highest value you see, this is the highest value, right, the high value, right, highest value, and you can see this is the lowest value. And also when you have a snowfall or icing thing, your coefficient of friction is drastically reduced. So there again controlling your brake is very tough and difficult also. In fact, they would see when the moment they have what do you call it, the snow falling, they try to do because of the snow is very loose, so they make it as a packed to improve the coefficient of friction. On top of that, they will pour what do you call gritty kind of granules. They will pour such a way that will improve the friction things. So by doing that, it will be avoid skidding aspect, okay. We will see the two different condition. So when you have a coefficient of friction for concrete, okay, I will use for concrete. Try to find out what happened to the your KB proportions for concrete surface. Just understand, concrete surface or road, usually that is mu s equal to 0.85 we taken, because this is vary between 0.8 to 0.9. So I choose as a mu s equal to 0.85, and your mu r, the rolling resistance mu r equal to 0.01. That's another thing you can choose as. Then h by L equal to 0.18, the value. This is for the light truck. For light truck I am talking about. Okay. So then the static load at the front axis L1 by L equal to 0.68. I think this should be the rear axle thing, okay, and L2 by L equal to 0.32. So can you tell me what is that the proportion KB front axle, kb rear axle. So what is the value you are getting? Supposed to have L2 H mu s mu r, okay, L1 H mu s plus mu r. If substitute the values, right, 0.32, 0.18, you have 0.85, right, your mu s mu r equal to 0.01 divided by 0.68 minus of 0.18, 0.85 plus 0.01. So you would expect it will come as a make it as a percentage. Normally it coming 4.7 and 4.53. Since we are talking about in terms of fractions, we can say straight away 47 by 53. So this is the proportion. This is the proportion. I think yesterday someone asked question. Okay, what they asked, in vehicle, the front we have a disc brake, at the rear we have a drum brake. Okay, so how does the proportion going to be work? That's a question was raised. Right. See, as I said earlier, the proportions are already carried taken care of by your wheel cylinder and hydraulic pressure, right. So whatever the x proportion will go to the front axle, whatever the remaining portion, maybe say as a y proportion, will go to the rear axle. Okay, so that is about the proportion only. That the remaining, so to meet the dynamics, right, we use different brake system. For rear we use the drum brake system, and for front we use the disc brake system. So as long as you meet the proportion, how does it matter, right? Is it clear to you? So the either disc brake, drum brake must be equivalent to whatever the proportion of you are getting. That's what you have to satisfy dynamically, right? So it doesn't matter whether you do it with the drum brake system or disc brake system, right? So this is for the concrete surface. Let's see what happen if we have a ice surface. Okay, if same thing, I just wanted to see the proportion how is going to be changed. For ice condition, ice surface. For ice surface, mu s usually is 0.1, right, very low friction, okay, coefficient of friction. So similarly, if you find out the kb front axle, the kb rear axle, right, I am just substituting straight away the values. So 0.1 is your mu s, okay, 0.01 is your mu r, yeah. So you would expect 0.34, 0.66, in other words 3466, your kb front axle, rear axle. So at any given time, your kb front axle plus kb rear axle must be 1, right. So that's need to be satisfied. So the question is, look at the what happened when your coefficient of friction is very low. Look at what is happening your rear axle, the proportion is changing, right, the proportion is changing. So this is the where we need to understand how to optimizing aspect also, okay. So the one thing is I would like to say, as I aware of that, the braking effect is happening, supposed to be happen at the same time on the both axles or 4 wheels, that is not happening. So what is the consequence you expect, right? So assuming that my front axle lock first, what do you think if the front axle locks first when you apply a brake? Is it good or bad, right? So loss of directional control. So the first thing is loss of direction control, causing the driver can't steer to the right or left. The moment you lock, right, the front axle lock, so the driver can't move the vehicle either to the right or to the left. That's a problem. So that's why it's called loss of directional control when you have a front wheel lock first. But good thing is there is no directional instability. I will tell you what does it mean. Okay. So because of the lateral movement of the front tire occurs, that there is a self correcting movement due to the initial force will try to push the vehicle to move into straight path. Okay. So it's allow when the vehicle is locked at the front axle, they allow the vehicles to move direct straight away to the direct path or straight line, but it won't allow to the right or left. That's what happening, right? So somewhere else you have to, then how do you do that? How will you do that? So the driver may detect the loss of steering and control by regaining release either fully or partially to release of the brake. So again, this is again depends upon the maneuvering of the driver skills is very important. So you have to play very smartly to operate your brake in such a way that either to release slowly or partially, such a way that you regain the control of the vehicle. Right. This is a if both front wheel lock first. Now the second thing is if both rear wheel lock first, right. So the front wheels track straight ahead, right, that is easier because of the front wheel keep rotating, it's moving straight, right. Now the rear wheel lock first, the rear wheel lock, what do you expect? What do you expect? Yes? Still you can change the direction. But what happened? They locked. So they see the moment when I say locked, the wheels can't rotate anymore. Please understand that. The wheels can't rotate. So rather they start sliding. They start sliding. My front wheels are rotating in the front axle, whereas rear wheels are not rotating, they are sliding. So that will create an imbalance. That will create an imbalance. Okay. That will create an imbalance. And remember, during the braking, certain mass also added to the front axle, whereas the mass is detected at the rear axle. So what do you expect now? Already I given the clue. The front axle is moving straight away with the heavy load, whereas the rear axle become lighter, but they are locked. So what do you expect now? Right, then they will start. That's why it's called directional stability. Okay, then the rear wheels deviate to the side. So until the vehicles can't track straight any longer, then the rear starts to spin around the front. That's what happening. It's called yaw action. Okay, so that's what happening. So it is more critical and difficult to control directional instability. Finally, you can see that what is happening now. So the vehicle will spin out. So which is so the spinning out is good. Do you think? It's not good, not at all good. Can you see the difference of when the front wheel lock first and the rear wheel lock first? Okay. So which is more important? So as a design engineer, you want to prefer at least the front wheel need to be locked first for safety aspect. For front wheel lock first, okay. Front axle I will say, front wheels only, right? Okay. For better safety. So what do you understand? So in the front wheel locks, you will have a directional loss of directional control, okay. Whereas directional instability not there, okay. The moment you have rear wheel locks, you will have a directional instability. That means it start spinning around, which is not good, okay. So the question is, how are we going to optimize it, right? That's where we're talking about the brake force distribution optimizations. The optimization means it is necessary to understand the condition at which the front and rear tires will lock first. At what condition? How do we know that? Further, how to quantify it? Right? Further, it is important to determine quantitatively which wheel is going to lock first. That's also we need to do that. Okay. Yeah. So now we'll try to go move around to try to find out the which will lock first aspect. So as I said earlier, remember you have a surface here, right? The road surface, the wheel is there. There is a heavy load. This is the vehicle weight, and moving in this direction. Okay. So obviously the rotation will be anti-clockwise. So this is the reaction force, and this is your braking force. This is what happened. Right. So the PB mu s into W. I'll say that. So everything we're talking about, I need to understand and quantify which will lock first. That means I'm talking about the deceleration rate aspect. The deceleration rate aspect I had to talk about. Okay. So obviously we know that the PB max, the front axle, right, is depends upon your mu s into n of a, right, that is there, and a PB max RA mu s n RA. So we have this this equation. Okay, maybe you can say as a C and D. This in these terms, PB max we have and NFA have, right, NF you have. Both we need to bring it with respect to deceleration aspect. Then we'll solve it and try to find out what exactly happening during the first front axle lock first, or if rear axle lock first. Okay. So our general equation, you know that the PB mu WR, which already we have done that, right, is equal to WGA, yeah, minus RA W sin theta. This was the general equation, right? Right. So here we are having, this is your rolling resistance or aerodynamic resistance. Aerodynamic resistance, right? It's the aerodynamic resistance. It's aerodynamic resistance, right? And this is your gradient. For simplification, what we are going to say, assuming that the vehicle is moving in the plain road, right? We'll assuming that the vehicle is moving in the plain road. So moment you say in this direction, this will be 0, and this also we neglect. So finally we will have a general equation PB mu r W equal to, this is the equation, general equation, right? This is a general equation. We are going to use this equation, okay? But we know already by NFA WL2 plus H PB mu r W divided by L. This is one thing, NFA. Similarly, your NRA, I will write here itself, minus H PB mu r W by L. We know that, yeah. So these things we know. Now we need to get this because as I said, we want everything the NFA, NRA with respect to deceleration aspect, okay. For that, what we are going to do, your NFA, right, WL2 plus rewrite H PB mu r W by L, yeah. So that is we know that. But we know from the general equation, what is general equation? PB mu R W equal to what? Wg by A, right? This already know general equation. So everything I am going to replace this term by putting this. Then the equation WL, I will take the W separately, then L2 A by G H, this is the equation, N of A. We will take the equation number 1 now. Similarly, NRA, what do you expect NRA will be here? WL, L1, right? L1 minus A by G H. This is equation number 2. So this is the way we do that, yeah. And we know that the braking force, this is the general one, the braking force must be summation of the braking force front axle plus braking force at the rear axle. That is one term, we know that. Similarly, the braking proportion KB FA plus KB RA. Remember, this is nothing but the braking force developed at the interface wheel and tire, that is the braking force, whereas KB is the distribution of your brake. So both are different, both are very different. So I need to find out individually, because I had to find out what exactly when the front axle is going to be locked or rear axle is going to be locked. So that means I need to understand what would be the real braking force at the front or rear alone. That is what I need to find out. So the braking force PB, right, to front axle alone, if I want to know that, I know this is my total one, right, this is my total braking force. So what are the proportion you are getting to the front, that is going to be here, right. So this is KBF, KB your front axle, right. So already we know that PB, what is the PB now? You have to keep the KB FA. Instead of PB, what we can you do that? From the general equation, your PB mu R W equal to Wg by A, right. So I want to know only the PB, right, that then this minus mu R W, this is what is going to come. So I am going to replace that. Mu R W. So if I take the W alone, the weight separately, it's KB FA W, it's A by G minus mu R. This is what your expression. So PB FA, okay, PB FA, we got it. So this is, we can take it as a equation number 3. This is braking force at the front axle. Similarly, the braking force rear axle, what do you expect now? Right. Your KB FA plus KB RA equal to 1, right. So already I know KBF. So anything 1 minus KB FA must be equal to your KBRA, right? Yeah, that's it. So by doing that, I can able straight away I will substitute 1 minus KB FA into A by G, right, mu R W. So this is equation number 4. This is equation number 4. So already we got it, yeah, right. So we know the equation. So so we got NFA, NRA, PBFA, PBRA, all 4 equation with respect to deceleration rate A by G. That's what we got in, right. So now we will find out the front tires approach lock first. So what do you expect? What do you expect when the front wheels need to be locked first? What do you expect? Your PB front must be equal to mu s into NFA, right? Yeah, NFA. Right. Already you know that what is the from equation previous equation you know that from equation 3 you can substitute for this, from equation 1 you substitute for NFA. When you substitute it, right, we will see that what is going to happen. Maybe I will move to the next slide. It will be much better. Your PB FA equal to mu s NFA. This is supposed to be happen. So I know this is should be KB FA W A by G mu R, right, must be equal to mu s divided by L L2 plus A by G H. This is what happened. So I will cancel out W W, that's already done. The remaining will be KBFA A by G minus mu R. Okay. You have mu S L L2 A by G H. This is what happened. Okay. Now I am going to separate these terms because I need to bring it up A by G at one side, the other things will be at the other side. Into A by G minus this term will come, right, mu s into A by G. I brought this side into H, that should be mu s L2 by L plus KB FA into mu R. Yeah. So if I take the common term A by G separately, right, so I would expect KB FA minus mu s by L H equal to mu s L2 by L plus KB F into mu R. Finally, I would need this A by G alone. Okay. So what I am going to do, one more term, I will multiply L so that I want to cancel out the L also. Shall I move to the next slide? Right. L minus mu s H by L is equal to L2 KB FA into mu R by L. Okay. So this also cancelled out. The A by G, since we are talking about the front axle, just bring it as a FA introducing mu s L2 this is what happened. So if I rearrange this equation, finally I would we arrive at a deceleration rate, right, A by G front axle mu s L2 by L, okay, plus KB front axle mu R divided by KB front axle minus of mu s HL. So this is the equation, okay, you will get it. This is the deceleration rate of the front axle, right. Question is, what happened to your rear axle now? What change do you expect now? Instead of L2 you will have L1, right. Instead of L1 you will have, so instead of L2 you will have L1, and the KBF has to be replaced with the 1 minus KBF, which is nothing but your distribution at the rear axle. That is one thing is there. Do you expect any sign change? Yes, this term will be changed, okay, this term will change. This is for a front axle. Similarly, for a rear axle, A by G RA, okay, mu s L1 by L plus 1 minus KB front axle, right, that gives mu R divided by 1 minus KB FA, again within the bracket. Here the sign will come, right, the sign will be, earlier it was minus sign, right, now the sign will change to plus mu s H by L. So this is the equation for the rear axle, okay. Now that is okay, but question is, now I got it, I got the deceleration rate for the both front axle as well as the rear axle. Then how do I know which will lock first? When do you expect which will lock first? When will you know? Right, when will you know? Okay. I have A by G front axle, right, A by G rear axle. So if my front will lock first, what do you expect the deceleration rate? Remember, we are talking about deceleration rate without taking the sign. Normally deceleration will be negative, right? We are not discussing anything negative aspect. We are taking the quantity as it is without any sign, because when we do the problem there will be confusion. So before that itself I am just giving a clarification. Let me ask, so when do you expect the front will lock first? When the deceleration rate less of the front axle less than the rear axle, the front will lock first. If the deceleration rate of front axle, right, greater than deceleration rate of rear axle, then your rear axle or rear wheel lock first, right. So when you have front wheel lock first, what happened? Loss of direction, right. When your rear wheel lock first, directional instability. So these are the things we are going to happen, okay. I think I will stop now. So we will discuss more on this aspect by solving the problems, okay. Thank you.